Welcome to Abstract Classes and Methods. In this lecture, we'll be looking at a couple of things. First of all, we'll be looking at abstract classes and abstract methods. And then once we understand exactly what they are, we'll look at how to implement that. And part of that starts with the abstract keyword. So let's start off by understanding exactly what an abstract class is. So an abstract class is a class that is not instantiated to an object. So as we know, usually when we have classes, we create these classes so that we can create objects out of them eventually. But the great thing, or the interesting thing about an abstract class is that you cannot create an object of an abstract class. Then you may be wondering, what is the purpose of an abstract class? Well, basically, an abstract class is kind of like a superclass that sets the foundation or sets the base for subclasses. Now, the subclasses are known as concrete classes, and they fill in the missing pieces in the abstract class. So the abstract class kind of sets the guidelines and the rules for what the subclasses need to have, and then the subclasses are the concrete classes from which you can create objects, and they are required to fill in the missing pieces. So that's what an abstract class is. It's basically used for organization and foundation so that we know exactly what the subclasses are required to do. So now, we've been talking a lot about these missing pieces that the subclasses have to fill in. Well, that's where abstract methods come in. So abstract methods are methods that are part of abstract classes, and they have no implementation. They only have the header. So basically what that means is if you have like public int void method name something, only that part is included in the abstract method. The code for that method is not included. And the reason this is used is because there's no default code that works for that specific method. Now let's say that we have a shape class. Now in the case of a shape class, we could have methods like area and perimeter, but those methods would be abstract because the area, the way to calculate the area or the way to calculate the perimeter is based upon whatever shape is created. So that's why in the shape class, which would be an abstract class, we would say that area is an abstract method and perimeter is an abstract method, so that whatever subclass inherits all these methods from this abstract shape class, the subclass must give an implementation for these different methods. So what we've done here is basically we've created kind of like a structure or an organization of what a subclass needs to go over. By creating area and perimeter as abstract methods, we've in essence forced the subclass to give an implementation in order to function, or to give some code for these methods. And keep in mind that abstract methods must be in abstract classes. So the methods in an abstract class, all of them do not necessarily have to be abstract methods, but if you have any abstract methods, they must be in an abstract class. So now we've been talking a lot about abstract classes, abstract methods. Now let's understand how exactly we tell the computer that we're using an abstract class or an abstract method. So what you would do is in the class declaration, you would say public abstract class shape. So that would be the class declaration. So simply what you're doing is everything stays the same. You're just inserting the abstract keyword in between public and class. Next, within this shape abstract class, we would have public abstract int calc area int w comma int l. So what we're doing here is this is just like a normal declaration that you would see, public int calc area. Again, what we're doing is we're inserting the abstract keyword, and what the abstract keyword is doing is it's telling the computer, okay, this is an abstract method. And what happens now is that's the only line we need for this calc area method, because as we know, the ability to calculate an area is dependent on what type of shape it is. So for this method, in this case, we would just say abstract int calc area, and what that does is we don't have to write any code for the method. We're just simply putting the method header, which is the second bullet point. That's all it is. It's just a method header, nothing inside braces, no body to this method, just the header is present, so that whatever subclass extends this shape superclass, it must define code for this specific method. So now that we've looked at an abstract class and abstract method, let's look at a subclass. So we have public class circle extends shape. So what we're doing here is, notice how here we don't have the abstract keyword and it's saying extend shape. So the shape is an abstract class, as we know. Now, because circle is the subclass of the abstract class shape, and the abstract class shape has an abstract method calc area, the circle is obligated to provide some code or an implementation for the calc area method. So for example, within this circle subclass, we would have public int calc area int w comma int l. So the first thing you can notice is that the method header is entirely the same as the method header is in the shape class. The only difference is that the abstract keyword has been removed. Now after this method header, as you can see within those braces, we would have code, which is whatever it can be. It doesn't really matter. It doesn't really matter what the code is. The important thing to note is that this abstract class abstract method is now having code provided for it in a subclass of an abstract class. So now that we understand what abstract classes are, what abstract methods are, let's move to Dr. Java and see them in a live programming environment. So here we are at Dr. Java. I have two files open. The first file is the shape.java file, and the second file is the circle.java file. So we're going to look at both of these files and understand how abstract classes work. So here we are in the we're in the shape.java file, and this is an abstract class. So we have public abstract class shape. So as we know, this is a regular class declaration. The only difference is that we're using the abstract keyword. So now when we look in this, when we look inside of this class, we see a lot of things that we usually see. We see a private instance variable, we see a constructor, we see a getter method, we see a setter method, all the regular stuff. Anything that you would expect in a normal class. Now the important thing to note is this last line over here. This last line is probably the most important line of this class, and that is public abstract int area int l comma int w. So what this is doing is, this is again, because of this abstract keyword, we know that it's an abstract method, and everything else remains the same. If I were to remove this abstract keyword, everything is how you would see it normally, and there will probably be some code after this. But we do have the abstract keyword, so this tells the computer that there is no code provided. So notice how after the entire header, I simply put a semicolon and I'm done. There's no code after this because it's an abstract method and therefore it needs no implementation. The only purpose of this area, this method, is just to let the subclasses know that you have to give me some code for this area method, because when you're a subclass extending shape, then you need to be able to calculate the area, and it basically forces them to do that. And that's the entire purpose of an abstract class. This abstract class shape in this case is setting a restriction or basically setting a restriction or setting a guideline for what its subclasses need to have. And the guideline it said is you need to have a public int area method. So now let's move to the subclass, the concrete class, and let's look at the circle.java file. So here we are in circle.java, and we can see in the declaration we have public class circle extends shape. So what we're doing here is, again, this is a regular declaration. We have the extends keyword, which tells us inheritance is happening. Now notice how the abstract keyword is not present because the circle class is not an abstract class. Then again, in the circle class, we're adding something like private int radius. We have a constructor. We're using the super keyword. All things that we are already familiar with. Now here comes the most important method of this class, and that is the public int area int l comma int w method. And what this is this method header is exactly the same as the method header in the shape abstract class, which is our super class. The only difference is that there's simply an abstract keyword in between public and int, and that's the only difference between the two. And now, because everything else is the same, the computer knows that this subclass is doing its job and it's providing the code needed for this specific it's providing the code for this abstract method, so it's fulfilling its requirement as a subclass of an abstract class. So by doing this, everything else remains the same. The abstract keyword is removed, and then whatever code is over here, remember, anything can go over here. It doesn't matter, you can write whatever you want, but everything else remains the same. This header remains the same, and that's very essential for something to happen. So again, just to recap what we've done, we had two classes, the shape class and the circle class. The shape class is an abstract superclass, and it has one abstract method area. Then we have the circle class, which is a subclass, and it's a concrete class because it's a subclass of the shape class. And basically, its important thing is that it provides an implementation of the abstract method, and that's what makes it fine. So we saw that this abstract method was used because we wanted to make sure that whatever the subclass was, whether it be circle, triangle, rectangle, anything, we want to make sure that the subclass follows the rules. And the rules we gave it is that it must have a method named area that performs the function of calculating the area. We set that requirement, and that's where abstract classes are used. This basically set the base or the foundation for the subclasses, and that's the purpose of the abstract class.